Hello everyone, welcome to this video on progressions topic. In this video we're going to talk about the harmonic progressions and then we do an overview on the arithmetic progression, geometric progression, harmonic progression. This is the third video of the progression series. If you have not watched the earlier videos, we do recommend you to watch the earlier videos which have covered the basic concepts of arithmetic progression and geometric progression. This would be an extension to those two videos. And this video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you're watching this video in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store, where you'll get to watch all these videos as part of a course and also get to practice a lot of questions that would help you enhance your understanding. So let's get started. What is harmonic progression? So we say that A, B and C are in harmonic progression if 1 by B minus 1 by A is equals to 1 by C minus 1 by B. Are in harmonic progression if they satisfy this relationship. Right? You can write this in multiple ways, but fundamentally what we need to understand is this: if A, B and C are in harmonic progression, then 1 by A, 1 by B and 1 by C are in arithmetic progression. So three terms in arithmetic progression, the second minus first should be giving us the common difference of that arithmetic progression. Third minus second should also give me the same difference, that is the common difference. That is what we are seeing here. Harmonic progression as a whole concept is something wrapped up in simple line like this, that if we are talking about three terms being in harmonic progression, the reciprocal of those terms 1 by A, 1 by B and 1 by C are in arithmetic progression. That's how we should be looking at and solve the problems. We don't have any specific formulae for the nth term, sum of terms for harmonic progressions like arithmetic progression, geometric progression. All we need to use is the reciprocals being in arithmetic progression and solve them according to that. Let's say if I say 2, 3, 6 are in HP, what is the fourth term? All I need to understand is I understand 1 by 2, 1 by 3, 1 by 6 are in AP. Right? What is 1 by 3 minus 1 by 2? Right? 2 minus 3 by 3 to the 6, that is minus 1 by 6. Similarly, the third and second term, 1 by 6 minus 1 by 3 will also give us 3 minus 6 by 6 3s are 18. So minus 3 by 18 is again minus 1 by 6. So the common difference is minus 1 by 6. That's why these are in AP. So what will be the next term? It should be 1 by 6 plus I have to add minus 1 by 6, that will be 0. So that's sort of a bit complicated situation. I'm seeing a 0 here. So 1 by 0 will be infinite. So you don't really get to write something like this. But technically if I got, let's say 1 by 4, let's assume that is the fourth term here. If I add the common difference I found out for this AP, the 4 would have been the fourth term of this HP. I'm just saying, but here because we landed up with 0 and 0 is 1 by 0 is infinite. So we are sort of getting into a complicated situation. But this would not happen if you get to see a question like this generally. So as I said, we don't have any direct formula to find the nth term for harmonic progression. Rather, we need to find an arithmetic progressions of the reciprocals and then do the reverse of it. But we do have a simple formula for the harmonic mean between two numbers. So if I say 2 and 6 are two numbers and I need to insert a harmonic mean between it, what do I mean by that? Let's assume that to be H. So 2H and 6 should be in HP. Right? So then I need to find H. So there is a simple formula, but generally I'll show you the normal way. So because this is what 2H and 6 are in HP, 1 by 2, 1 by H and 1 by 6 would be in AP. So this term minus this term should be equal to third term minus second term, that is 1 by 6 minus 1 by H. So let me send 1 by 2 to this side and minus 1 by h to this side. Minus 1 by h will become plus 1 by h. So that is 1 by h plus 1 by h is equals to 1 by 6 plus 1 by 2. So this is 2 by h is equals to 6 2s are 12 and 2 plus 6 8 by 12. So 2 1s are 2, 4s are 4 1s are 4 3s are. So h is basically coming out to be 3. So I know if 2 and 6 are two numbers and I need to insert a harmonic mean in between, the harmonic mean is 3. This is a bit complicated, I mean to say the calculations wise. Let's assume A, B, I'm trying to say A, B and C are in HP. So B is technically the harmonic mean of A and C, right? So as we said, 1 by B minus 1 by A is equals to 1 by C minus 1 by B. So I send this side and this side. It will be 1 by C plus 1 by A. 1 by B plus 1 by B will become 2 by B. So this is AC, A into C, A plus C, 2 by B. So B equals to 2AC, A plus C, I'll get it here. So the harmonic mean of two numbers of A and C can be calculated as 2 into number 1 into number 2 by number 1 plus number 2. I'll show you for this case, right? Harmonic mean for 2 and 6 is 2 into the first number is 2, second number is 6 by 2 plus 6, 4 6 are 32, sorry 2 2s are 4, 4 6 are 24, 2 plus 6 8, 8 1s are 8 3s are, so harmonic mean is 3, which is what we calculated here. So this formula is a very useful formula to remember. Harmonic mean for A and C turned out to be 2AC by A plus C. So arithmetic mean, geometric mean and harmonic mean, we do have a relationship between all three of them. Arithmetic mean is, if I am talking about A and B are two numbers, what is the arithmetic mean of A and B? A plus B by 2. What is geometric mean? Square root of AB. And what is harmonic mean? If you remember, it is 2AB by A plus B. Let me multiply arithmetic mean into harmonic mean. What do I get? A plus B by 2 into 2AB by A plus B. These both will get cancelled out and 2 will get cancelled out, and I am getting AB, which is geometric mean square, right? Square root AB is geometric mean. What is the square of geometric mean? That is AB. So that is what we got. So the relationship between AM and GM and HM is arithmetic mean into harmonic mean is equals to geometric mean square. Right? You can frame questions in multiple ways. Like let's say the arithmetic mean of two numbers is 6. The harmonic mean is, let's say, 4. Then what is the product of these two numbers? So I know 6 is arithmetic mean, harmonic mean is 4. So geometric mean square is this. So 24 is geometric mean square. What is geometric mean square? Product of those two numbers square. I am asking you to answer what is the product of two numbers. That is 24. Now you can solve questions like this using this logic. This is one key point to know. Another key point, which is an inequality, which is a good relationship that might help sometimes. Arithmetic mean is always greater than or equals to the geometric mean is greater than or equals to harmonic mean. When will this equal to happens? Only when these two values are same. What is, if let's say A equals to B equals to 1, for example. What is this? 1 plus 1 by 2 is 1 plus 1, 2 by 2 is 1. What about geometric mean? Square root of 1 into 1 is again 1. Harmonic mean is 2 into 1 into 1 by 2 plus 2 is equals to, 1 plus 1 is equals to again 2 by 2 is 1. You see, arithmetic mean, geometric mean and harmonic mean, all of them are equal only when I know both the numbers are same. Not necessarily equals to 1, could be 10, could be 3.5, any value, but the rule is these two should be equal. Right? If I say the arithmetic mean of a number is 10, so arithmetic mean of two numbers is 10, and arithmetic mean is equals to the geometric mean, what are the two numbers? Technically both of them have to be 10 and 10. That case, why? From this clue I understand both the numbers should be equal. And what is arithmetic mean? A plus b by 2 equals to, they gave it as 10. So 20 is the sum of two numbers, 2 into 10. So I know both of them are equal, they both have to be 10 and 10. Now I can solve questions like this. Otherwise, arithmetic mean is always greater than the geometric mean, and the geometric mean is always greater than the harmonic mean. This is also a useful relationship to solve some problems. Let's keep this in back of your mind. Let's move ahead. So till now we have seen arithmetic progression, geometric progression, harmonic progression to some extent. And if you have seen the earlier videos, we've talked about how to find the sum of numbers, nth term, and etc. etc. So those are the standard series that would be helpful for you to solve if the question asked is fundamentally coming from those standard series. Not always we'll see questions framed on those standard series. There are some non-standard series as well. So it's difficult to say it's part of progressions or sequences, but we are discussing all in this bucket only. It's good to know. It's more to do with your logic or some intelligent way of figuring out a way to calculate a non-standard series. It's not more of a concept, it's more of a technique or more of a habit of figuring out the easiest way to solve it. So let's look at this, right? 1 by 2 plus 1 by 6 plus 1 by 12 plus etc. The immediate thing that I would look for is this a geometric progression? So 1 by 6 by 1 by 2 is 1 by 3. 1 by 12 by 1 by 6 is 1 by 2. See, the common ratio is not common. So it's not a geometric progression. Is it an arithmetic progression? 1 by 6 minus 1 by 2. What do I get? 6 2s are 12, 2 minus 6, that's minus 1 by 3. 1 by 12 minus 1 by 6 is going to give me 6 minus 12 by 12, 6 are 72, that's minus 1 by 12. Again, common difference is not same, it's not AP as well. Okay, I have one more hope, that's HP. If 1 by 2, 1 by 6, 1 by 12 are in HP, then technically 2, 6, 12, so on should be in AP. What is 6 minus 2? 4. 12 minus 6 is 6. This is also not a arithmetic progression. So it can't be HP as well. So what is the way to solve it? So these type of questions generally would have a simple logic, but that logic sort of varies depending on the question. So we need to have a practice of different kinds of non-standard series, and through that practice we'll be able to solve this over time. So for example, this question, they've given the nth term is this, right? 1 by something into something. So all of these sort of questions, the immediate logic that you should try is this. What is technically this? What is this? 1 by 1 plus 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on is this series. 1 by 2, 1 by 6, 1 by 12, and I need to do till 1 by n into n plus 1. So what is this? I can write this as 1 minus 1 by 2. 1 by 2 into 3 can be written as 1 by 2 minus 1 by 3. You see this when I add 1 by a, when I do 1 by a minus 1 by b, LCM of a and b, that's one way to do. The other way is not looking so closely at LCM. I simply do this, right? A into b, b minus a. If these two numbers are consecutive, like n into n plus 1, here 1 into 2, 2 into 3, I'll always get this to be 1, and then I get a product of a into b. That is what this series is looking, right? 1 by 2 into 3. 1 by 3 into 4 will look like 1 by 3 minus 1 by 4. And so on. Sorry, it's a plus, right? And so on. 1 by n minus 1 by n plus 1. If you say this, this is minus 1 by 2 and this plus 1 by 2. Minus 1 by 3 plus 1 by 3. I can keep cancelling till this part. What will I be left with? 1 minus 1 by n plus 1. First term of this first split and the last term of the last split would be the only things which will not get cancelled out, and I will be left with this, and I can simplify it. N plus 1 minus 1 by n plus 1. So the answer is n by n plus 1. This is one smart way to solve this. Would this technique always work? If I see in other non-standard series, it might not work. You just have to be building those techniques through practice, different types. But what I'm trying to say is these are also some series that could get popped up in exams. You just need to understand that you cannot classify every series that you see as a arithmetic, geometric or harmonic progression. You got to learn some techniques to solve non-standard series as well. For example, another technique that would really help is using approximation. This will be decreasing series 1 plus 2 by 3, 3 by 3 square, 4 by 3 cube, 5 by 3 power 4. You see, if it was just 1 plus 1 by 3 plus 1 by 3 square plus 1 by 3 cube plus 1 by 3 4, this could have been a simple geometric progression to infinite terms. But this is not. I can also go ahead and do this in this way. 2 by 3 can be split as 1 plus 1 by 3 plus 1 by 3. 3 by 3 square can be split as 1 plus 3 plus 3 square, 3 square, 3 square, and this will be like this, right? So I pick 1 plus 1 by 3 plus 1 by 3 square plus similarly 4 by 3 cube can be split into 4 times. And what do I get if I pick the first term of all of this? I'll get a simple geometric progression sum to infinite terms. So then I'll have 1 by 3 plus 1 by 3 square plus 1 by 3 cube. Second term of all the expansions, I don't have another one, so I'll straight away start with 1 by 3 square and again infinite terms, plus I start off with 1 by 3 square for the third term, 1 by 3 cube, 1 by 3 power 4. Similarly, the next will be starting off with 1 by 3 cube plus 1 by 3 power 4 and so on to infinite terms. Let me do one thing. One second. Right. Now I have written this. So what is the sum for this? 1 plus so on. The common ratio is 1 by 3. A by 1 minus r is the sum to infinite terms for a geometric progression, right? So the first block would give me 1 by 1 minus 1 by 3, that is 1 by 2 by 3, 1.5. Right. Similarly, the second block starting from 1 by 3, I will get 1 by 3 by 1 minus 1 by 3, that is 1 by 3 by 2 by 3 equals to 1 by 2. What will be the third block? 1 by 3 square plus 1 by 3 cube, so on. So I am starting off by 1 by 3 square by 1 minus 1 by 3 will be 2 by 3. So if you see, right, the first block is 1 by 2 by 3. The second block is 1 by 3 by 2 by 3. The third block is 1 by 3 square by 2 by 3. So if I add all the blocks, what would I get? 1 by 2 by 3 plus 1 by 3 by 2 by 3 plus 1 by 3 square by 2 by 3, 1 by 3 cube by 2 by 3 and so on. If I take 2 by 3 common, right, so it will be 1 by 2 by 3 into 1 plus 1 by 3 plus and so on 1 by, so infinite terms, right. Again I see 1 plus 1 by 3 plus 1 by 3 square, I am taking only the numerators. I again see an infinite series of geometric progression that will turn out to be again 1 by 2 by 3. So this will be 1 by 2 by 3 is 3 by 2 into this entire thing will be again 1 by 2 by 3 is 3 by 2, that is 9 by 4 is the correct answer for this. Now this is really a complicated way of solving it. I understand. I'm not denying this. If you're confused, I strongly recommend you to look at this again. To pass, go back and check this. What did we do? We just kept splitting them so that I get multiple infinite terms. So I'll tell you another thing, right? Unless the options are pretty close. What is this value? 9 by 4. 9 by 4 is 2.25, right? So let me show another way, which is something that I can do using approximation. Other technique I'm saying. If the options are very helpful, we can indeed do this and get away with easier way to solve this question. You don't really have to complicate and make this difficult. If the options are pretty close by, like everything was 2.2, 2.5, 2.3, then yes, I understand it's difficult to solve using what I'm telling, but the likelihood of seeing that is low. So let me show this, right? What is the value of 1 is 1, 2 by 3 is 0.66, 3 by 9 is 3 by 3 square is 3 by 9, 1 by 3 it's 0.33. What about 4 by 3 cube? That is 4 by 27. It's approximately 0.15, I would say. I'm just taking 40 by 27, that will come as 1.5, something like this. So approximately 0.15 is a decent estimator. 5 by 3 power 4 is 81. So this will come to be 0.86 or 480, so 0.06. If you go further, right, 6 by 243, it will be like much smaller, like 0.03. Further down, 7 by 729 would be 0.01, right? 700 by 729, 0.0. Approximation, like it's actually less than 0.0. It should be 0.009 something. But beyond that, everything will be much smaller. Okay, I'll be only getting the decimal places of much smaller and smaller, 0.0000. What is the sum of this? 1 plus 0.6, 1.66 plus 0.33 is 2, 2.15, 2.21, 2.24, 2.25. And then something should be something like this, right? You see, this is the right answer, right? Just do for first 5-6 terms. Beyond this, all you'll get is, even if I have approximated, that's why we got 2.25 just for first 6 terms. If I find the exact values as 0.09 something, 27 something, etc., you'll actually not get, you'll get 2.23, 2.24. With all the terms to the infinite, I'll be getting exactly 2.25, an approximation. So this is a much effective method, even if you can't figure out the way I've solved, right? All of this is not easier for sure, but this approximation will work for most number of times, unless the options were like 2.2, 2.25, 2.3, etc. This is definitely a difficult situation to be in, but we don't expect to see options like this, so don't worry. Most probably approximation should work. But keep this in mind, you don't get to see only standard series, you also get to see some non-standard series which are not an arithmetic, geometric or harmonic progression. Be ready for that to solve problems. Some other techniques that would help you to solve some questions, right? One common thing that would be helpful to start off with, if I get to see a question talking about 3 consecutive terms of an arithmetic progression, I don't know what is the first term, I don't know what is common difference. The good logic of taking is this: I take the first term is a minus d, the second term is a, and the third term is a plus d. Here the first term is a minus d, I understand this. The second term is this. But what is the advantage? When I say sum is 18, I just need to do this is first term plus second term plus third term, a plus d is 18. If the way we have written, we can easily cancel out a minus d plus d plus d minus d. I'll have 3a is equals to 18. So a is 6. I don't know what is my first term yet, right? I know the middle term is 6. From the given information, I can only comment on that. This could be 4, 6, 8, or it could be 3, 6, 9. All of them will satisfy the condition of 18. We don't know the d yet. There should be some other clue that should help me. Beyond that, I can continue solving, but it's a good way to assume 3 consecutive terms on AP. If I say 5 consecutive terms, start off with a minus 2d, a minus d, a plus d, and a plus 2d. All of them will cancel out, minus 2d plus 2d minus d plus d. So if a question is talking about sum of 5 terms or average of 5 terms is so and so, I can immediately find this middle term. Similarly, product of 3 consecutive terms of a GP. So if I say GP terms, I can assume them to be A, AR, AR square and so on, AR cube, etc. Other way, if it's 3 consecutive terms, I'll start off with A by R, A and AR. Why? If I multiply them, I'll get A by R into A into AR. R and R will get cancelled out. That's given as 27. A cube is equals to 27. A will come to be 3. So that's the middle term. I don't know the previous term is 3 by R and next term is 3R. I need to know the R value to give the answer, but that is still easier to solve it. If I go ahead and do this way, right? What do I get? A into AR into AR square is equals to 27. I'll get A cube, R cube is equals to 27. So AR is equals to 3. That is still the middle term. I can still answer it. There is nothing wrong in this. It's just that it might be a bit difficult for us to use that and solve it in an easy manner. So stick to whatever suits you, but make sure that you keep this in mind, that it might help you to solve problems easier, assuming the terms of an AP and GP. Then this is again sum of natural numbers. You can call them, like for example, the sum of first n natural numbers is 1 plus 2 plus 3 and so on up to n. Like if the question asks what is the value of 1 plus 2 plus 3 and so on up to 10. Right? This is arithmetic progression with a common difference of 1 and arithmetic, the first term is 1 and the common difference is 1. I can do it. There is a simple formula which you can directly remember and you can keep using them again and again. N into n plus 1 by 2 is the sum of first 10 natural numbers. For the first 10 numbers, it is 10 into 10 plus 1 is 11 by 2. 2 5s there, it is 55. Similarly, the sum of squares of first 10 natural numbers, that is 1 square plus 2 square plus 3 square plus 4 square. If you see this is not a geometric progression, arithmetic progression. So the formula for this is n into n plus 1 into 2n plus 1 by 6. So what is the value for the first 10 squares? It will be 10 into 10 plus 1, 11 into 2 into 10, 20 plus 1, 21 by 6. 3 2s are 3 7s are 2 1s are 2 5s are. It will be 35 into 11, 385. That will be the value for the first 10 squares sum. What is the sum of cubes of first n natural numbers? That is 1 cube plus 2 cube plus 3 cube and so on to n cube. It's similar to this formula. I just need to add a square on top of it. N into n plus 1 by 2 square. Sorry if it's confusing, right? Yeah. So what is n into n plus 1 by 2 for the first 10 numbers? I know 55. So if I am asking about what is the sum of first 10 natural number cubes, so that's 1 cube plus 2 cube and so on up to 10 cube. It is basically n into n plus 1 by 2 is 55. 55 square. If you know the shortest way of solving 55 square, it will be 3025. 55 square is 3025. That is the value for the first 10 cube sum. Sum of first n even numbers, that is 2 plus 4, 6, 8 and so on. The way you can do is this. If you see, it's not up to n, it's up to 2n. That's because we are talking about first n even numbers. If I am talking about first 10 even numbers, what are those? 2, 4, 6, 8, so on up to 20. These are my first 10 even numbers. The way to look at this is this. If I take 2 common, I'll get 1 plus 2 plus 3 and so on up to n. Because I know this is n into n plus 1 by 2. I have a 2 outside, I'll get them cancelled. So simply the formula will turn out to be n into n plus 1 by, sorry, that's it, n into n plus 1. If it is up to 2n, 2, 4, 6, 8 up to 20, then n is 10, not 20. Keep that in mind. Using that, the formula would be 10 into 11, that is 110. Similarly, the sum of first 10 odd numbers, 1 plus 3 plus 5 plus so on up to 2n minus 1. You see, this I can write like this. 1, I add plus 1 and then subtract minus 1. Plus, right? 3 plus 1 and minus 1. And so on up to 2n minus 1 plus 1 and minus 1. Why did I do this? Plus 1 minus 1 plus 1 minus 1, all of them will get cancelled out. It won't change the value. 1 plus 1 is 2, 3 plus 1 is 4, 5 plus 1 is 6, 2n minus 1 plus 1 is 2n. Right? I have not counted this yet. intentionally. I'll come to that. So I have how many minus 1s? 1, 2, and for nth term I'll have minus n. This is known to us, right? 2 plus 4 plus 6 plus 2, and I've shown n into n plus 1. So this will turn out to be, it's minus n. N into n plus 1. This is for the sum of these even numbers. I just need to subtract minus n. So n into n is n square plus n minus n. They get cancelled out. We simply land up with n square. You see, what are the first 10 odd numbers? 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. See, what is the 10th number? 2 into 10 minus 1, that's basically 19, right? That's how we write the odd numbers, 2n minus 1 form. So for n odd numbers, it is n square. So for 10, it will be n square. So 10 square is, so that's the value for the sum of 1 plus 3 plus 5 and so on up to 19, the first 10 natural odd numbers. Now these are useful techniques that would help you to solve questions in easier and faster manner. Keep this as back of your mind. Through practice you have to remember this, these formulas. So let's move ahead and solve some practice questions. If 2, 3 and C are harmonic progression, what is the value of C? We know that if 2 and 3 and C are harmonic progression, one way to look at is 1 by 3 minus 1 by 2 equals to 1 by C minus 1 by 3, because I know 1 by 2, 1 by 3 and 1 by C are in AP. So the common difference must be satisfied. I can do it. Other way, if I know that 3 terms A, B, C, so B must be the harmonic mean of A and C, right? So B should be equal to 2AC by A plus C. If you remember the formula we discussed in the beginning. So B is 3, A is 2, C is the one which we need to find, that is 2 plus C. Cross multiply, 2 2s are 4C is equals to 3 2s are 6 plus 3C. It goes this side. 4C minus 3C C is equals to. So we calculate the value of C to be 6. We'll get the same answer if I solve in this view also. Nothing different. It's just about how comfortable you are with the fractions. If the ratio of the harmonic mean of two numbers to the geometric mean is 4 by 5, find the ratio of the numbers. So what is the harmonic mean? If I assume A and B are the two numbers, 2AB by A plus B is the harmonic mean. What is the geometric mean? Square root AB. The ratio is HM by geometric mean GM is equals to 2AB by A plus B by square root of AB is given as 4 by 5. So how would I get this multiplied? This by this is written like this. So 2AB by A plus B into 1 by square root AB, right, is equals to 4 by 5. I cancel this, I'll get square root AB. So let me cancel 2 and 4 as well, 2 2s. So I'm ending up with square root AB by A plus B as 2 by 5. Let me now write the reciprocal of this. That is A plus B by square root AB should be equals to 5 by 2. So A plus B by square root AB can be written as A by square root AB plus B by square root AB. A by square root AB is, I cut square root A, I'll get square root A here, I'll still have square root B. Square root B gets cancelled out, I'll get square root B in the numerator and square root A. So this will translate to be square root A by B plus square root of B by A is equals to 5 by 2. You see, they're asking for the ratio of numbers, right? So that is basically I need to find A by B. Let me assume this to be R. So what is this? R, let me put this rather square root of A by B as R. So what is the ratio of numbers? A by B is R square. So if I find R, I just need to find the square of it to find the ratio of numbers. So square root of A by B is R. What will be square root of B by A? That will be 1 by R is equals to 5 by 2. I just need to solve this to get the answer. So this will turn to be a quadratic equation. R square plus 1 is 5 by 2. I cross multiply, we'll get 2R square plus 2 is equals to 5R. So 2R square minus 5R plus 2 is equals to 0. We need to solve this. to get the roots. If you know the way to solve, the roots are minus b plus or minus square root of b square minus 4ac by 2a. We'll discuss about this in the later equations. If you are not aware of it, don't worry about this. Till this point is what you need to be comfortable with. We'll anyway cover the other concepts that would help you to solve this equation. So solving this, b is minus 5, so minus of minus 5 plus 5 square 25 minus 4 2s are 8 to the 16 by 2 2s are 4, 5 plus or minus square root 9 is 3 by 4, so 5 plus 3 is 8 by 4 is 2, or 2 by 4 is 1 by 2. So r values are 2 or 1 by 2, and what is r square is what I need, right? So that will be 4 or 1 by 4. So the ratio can be 4 by 1 or 1 by 4. Both of them would still give me the same. It's the same value. This is a bit complex, but we've given this example to show you how you should be, right, comfortable with these formulas and come to this stage. This is the important juncture to come, and then making this into quadratic equation. All of this is something we'll discuss in algebra concepts. If you are not comfortable yet, don't worry about that. Till this point is what you need to be able to come. After that, we'll anyway discuss this in later concepts. Find the value of n when n is equals to 1 into 3 plus 3 into 5 plus 5 into 7 and so on up to 21 into 23. Again, this is a non-standard series. You check, it won't be any standard ones like HP, HP, GP. So how do I write this? So let's write this as nth term. If I see ratios, right, 1 by n something something, which we have solved in earlier video, like earlier part of the video, where we split them as 1 by n minus 1 by n plus 1 etc. to cancel them out. That's one technique you can see when it's to do with all the values without fractions, right? 1 into 3 plus something into something. There's one way you can try, that is basically try to first find the nth term. So this term can be written as is, okay, the nth term of this series, like 1 by 3 is first term, this is the second term, this is the third term, sort of it. 2n minus 1 into 2n plus 1. If I see odd numbers, that's something that immediately strikes to me. Why? If the nth term, right, what is the first term when n is equals to 1? The first term is t1. 2 into 1 minus 1, 2 ones are 2 minus 1 is 1. 2 ones are 2 plus 1 is 3. n is equals to 2. The second term is 2 2s are 4 minus 1 is 3. 2 2s are 4 plus 1 is 5. See, this is what we are getting here, right? What will be this? When n is equals to 11, t11, 2 into 11, 22 minus 1 is 21 into 22 plus 1 is 23. So basically these are 11 terms and I need to find the sum of them. So how do I write this? So this series is basically 2n minus 1 into 2n plus 1 is each term, and I write a summation symbol because I am adding them, plus plus, where n is starting from 1 to 11, right? The first term to 11th terms is what I am adding. So this is fundamentally writing like 1 into 3 plus 3 into 5. So this is n is equals to 1. This is n is equals to 2. I am adding, right? The for plus I am putting the summation. So what is 2n minus 1 into 2n plus 1? 4n square minus 1, and summation is n is equals to 1 to 11. Now for summation you can do this. I can put the summation symbol for both, that is summation of 4n square minus summation of 1, n is equals to 1 to n, so 1 to 11, n is equals to 1 to 11, and if I see 4n square, a constant will come out of the summation as well. 4 summation of n is equals to 1 to 11 n square minus summation of n is equals to 1 to 11 1. So what should I do here? See, what is the summation of n square 1 to 11 is fundamentally, let me use a different color for this, one second. N square basically means 1 square plus 2 square and so on up to 11 square, because n is 1 square, n is 2 square, right? I just need to do the same, right? And we know the formula for this, right? Sum of squares of natural numbers is n into n plus 1 into 2n plus 1 by 6. So the first 11 squares, it will be 11 into 12 into 23 by 6. 6 1s are 6 2s are. I get 22 into 23. I will be 22 3s are 66. 22 are 44 plus 6 506. This is the summation value. What about the summation of n is equals to 1 to 11, 1? You know, if this is a constant term, it's basically writing like 1 plus 1 plus 1 plus so on up to 11 times. This is when n is 1, this is when n is 2, this is when n is 3 and so on up to when n is 11. So 11 times I add 1, it should be coming to be 11. So this will translate to 4 into summation of n 1 to 11 n square is 506. Minus this will be 11, so it will be minus 11. So 4 into 506 is 2024, minus 11 is 2013. Again, this is a complicated one. Indeed, this is one of the CAT questions with minor changes in the values and stuff, but the logic and the way to solve is the same. So this is what you should be expecting in CAT level. This is definitely not an easier question even by the CAT standards, but through practice you can get away with this non-standard series. All the non-standard series, if I am not saying denominators, one of the useful logic is trying to get them into this nth term logic and then see sum of n square, sum of n cubes, or sum of n, etc. Right? Then this find the value of 11 square minus 12 square plus 13 square 4 up to minus 20 square. How do I do this question, right? So this one logic is this. I'll show you which I feel is easier in this. 11 square minus 12 square. What is a square minus b square? A minus b into a plus b. So 11 square minus 12 square will turn out to be 11 minus 12 into 11 plus 12. 11 minus 12 is minus 1 into 11 plus 12. I'll keep that aside for now. I'll show you. What is this finally? Minus 11 minus 12. Similarly, what will I get for 13 square minus 14 square? 13 minus 14 is minus 1. 13 plus 14. I'll not find this. I'll keep them as it is minus 13 minus 14. 15 square minus 16 square should also come out to be minus 15 minus 16. 17 square minus 18 square would also come out to be, and 19 square minus 20 square is the last one. It will also turn out to be minus 19 minus 20. So finally the entire expression will translate to minus 11 minus 12 plus minus 13 minus 14 plus and so on up to minus 19 minus 20. So it's basically writing minus 11 minus 12 minus 13 minus 20. So if I keep minus 1 common, it will be 11 plus 12 and so on up to 20. Now if I find the value of 11 plus 12 and so on up to 20, I can find the final answer, right? As simple as it. So when we get to see questions like this, I know how to find 1 to 20 but not 11 to 20. The thing to do is this. Sum of first 20 terms minus sum of first 10 terms should give me sum of 11 to 20, right? 1 plus 2 plus and so on up to 20 is this sum of first 20 terms, minus 1 plus 2 plus and so on up to 10. If I do, I'll cancel 1, 1, 2 and so on up to 10. I'll have 11, 12, 13 up to 20 left. I know how to find the first 20 terms. I know how to find first 10 terms. What is the formula for first 20 terms? N into n plus 1 by 2. The first 10 terms will be 10 into 10 plus 1, 11 by 2. Right, this will be 2 tens are 10 into 2 and 2 and 0 minus 55. 210 minus 55 will be 155. This is the final answer. So that's the value for 11 plus 12 plus 1 up to 20, and I have a minus sign before, so I should be getting minus 155. Similarly, if a question asks find the value of 11 square to 20 square, I know the formula for the first to 20 squares. I subtract 1 square to 10 square, then I'll be getting the 11 square to 20 square, right? That is how we keep doing for these things. So all you need to play around with these formulas only, but it's just about, you know, it might not always start off with 1, so you just need to tweak a bit to get to what is required. So everything that can be called as a progression, sequence or series, you know, to find the sum nth terms have been discussed in all these 3 videos. Especially this video is a bit complicated. It's gone into some slightly advanced level with respect to the problems. So If you are watching this video in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store. You'll get to watch these videos and also get to practice hundreds of questions that would help you to enhance your understanding. Also, like our partners Facebook page, we are coming up with a lot of courses and updates will be shown in this page, so don't miss that. Thank you for watching this video, and let's meet in the next video.